In this video, I'll go over basic stoichiometry dealing with the amount of reactants. So in this problem, I have 96.1 grams of propane, and I will determine the mass of oxygen needed to fully react with that. So the process I'll go through will be the grams of propane, so C3H8, convert that to moles of C3H8, convert that to the moles of O2 using the chemical formula above, then converting that to grams of O2. So I have 96.1 grams of C3H8. So we're going to divide that by the molar mass of C3H8, which is 44.1 grams. And that's for every 1 mole. So you can see that the units will cancel out of grams, leaving us with moles, which is 2.18 moles of C3H8. Now we can take that value and use it to convert to moles of O2. So as above, we can see that for every 1 mole of propane, 5 moles of oxygen is used. So let's write out that ratio. And then you can see that units cancel out. That'll give us 10.9 moles of O2. Now we can convert the moles of O2 to grams of O2, which is what we're going for. So for every 1 mole of O2, there's 32 grams of O2. And that'll give us 349 grams of O2. And that's what we were trying to solve for. But let's say instead of trying to solve for oxygen, we were solving for the mass of CO2. So we already know the moles of propane. So let's write that out. And then then we reference the chemical equation in again. So we have 1 mole of C3H8. Now will yield 3 moles of CO2. So write out that ratio. So 1 mole C3H8 will yield 3 moles CO2. Now equals 6.54 moles of CO2. Now we can convert the moles of CO2 to grams. So for every 1 mole of CO2, that is 44 grams. And that's going to be equal to 288 grams of CO2.